Today we are going to balance redox equation in basic medium. The steps are simple. First, you balance the equation as in acidic medium. We use S, E, O, H, C and A to remember the steps. Then, we will add O, H minus to both sides of the equation. For example, balance the following redox reaction in basic medium. First of all, the letter S means separate, so we divide the equation into oxidation and reduction. If we calculate the oxidation number of iodine, it is +5 on the left side and -1 on the right side. So, iodine undergoes reduction and chromium undergoes oxidation. Next, the letter E means element. We need to balance elements other than hydrogen and oxygen. In oxidation reaction, there is 1 chromium on the left side and 1 chromium on the right side. While on reduction, there is 1 iodine on the left side and 1 iodine on the right side. Hence, the elements are already balanced for both oxidation and reduction equation. Next, the letter O means oxygen. We need to balance oxygen by adding H2O. In the oxidation equation, there are 3 oxygen on the left side and 3 oxygen on the right side. So, there is no need to add H2O here. While, in reduction equation, there are 3 oxygen on the left side but no oxygen on the right side. So, we should add 3 H2O here. Hence, the equations will be as follows. Next, the letter H means hydrogen. We need to balance hydrogen by adding H+. In the oxidation equation, there are 3 hydrogens on the left side but no hydrogen on the right side. So, we should add 3 H+ here. While, in reduction equation, there is no hydrogen on the left side but 6 hydrogens on the right side. So, we should add 6 H+ here. Hence, the equations will be as follows. Next, the letter C means charge. We need to balance the charges by adding electrons. The electrons are added on the right side of oxidation and the left side of reduction. In the oxidation equation, the charges on the left side is 0 while on the right side is +1. So, we should add 1 electron on the right side. In the reduction equation, the charges on the left side is +5 while on the right side is -1. So, we should add 6 electrons on the left side. The equations will be as follow. We must make sure that the number of electrons in oxidation equation and reduction equation is the same before we proceed to the next step. In this case, we should multiply the oxidation equation with 6 to get the same number of electrons as in reduction equation which has 6 electrons. Last but not least, the letter A means Z. We add both the oxidation and reduction equations. Cancel the electrons. We should also cancel species that appears on the opposite sides and add together species that appears on the same side. In this equation, we cancel the electrons, and we cancel 6H+ on the left side with 18H+ on the right side. So, the remaining H+ on the right side now is 12H+. The overall equation will be as follows. If you are balancing redox equation in acidic medium, you should stop here. If you are balancing in basic medium, there are a couple of steps to follow. If we are balancing in basic medium, we should move to next step which is add O, H minus to both sides of the equation. The number of O, H minus to add depends on how many H+ are there in the equation. In this case, there are 12 H+ in the equation. So, we add 12 O, H minus to both sides of the equation, left and right sides. Next, 12H plus 12 O, H minus are equal to 12 H2O. So, we cancel them in the equation and hence the equation becomes as follows. The last step is to cancel species appears on the opposite side and add species appears on the same side. In this case, we add 3H2O to 12H2O and we get 15H2O. The final overall equation will be as follow. Finally, make sure your equation has the same number of atoms and total charge on both sides, left and right. Now, it's your turn. Complete exercise 6 and upload your answer in the attendance form.